Alan here. Just wanted to show the CNC lathe project that I've been working on for about 6 months. It's done. It's complete, and turned out pretty nice. Pretty happy with it. So this is it basically. Some of the parts of the project. One part of the project was replacing or adding this 6-inch 6-jaw set true or run true type chuck. I had to machine a custom back plate for that. The thread on this spindle is a bit unusual. It's 1 3/4 inches by 8 threads per inch. That's kind of unique to, I think, this lathe. I don't know any other lathe that has that thread, so I had to custom make the back plate and machine it. Nice thing about these set true or run true chucks is they've got adjustments here for Allen bolts on the outside that you can adjust, and there's a boss on the faceplate that these bolts tighten down against. And using these 4 bolts, you can adjust the run out of the chuck. So the run out on this chuck is about 7/10,000ths of an inch, which isn't too bad at all. So so that's the chuck. That was one part of the project. Then of course there's the mechanical aspects of converting it to CNC. Originally I had set out to use some plans that I got off of CNC Zone and custom machine all the parts using those plans. I decided not to do that. Actually, I found this kit that other folks have been using. It's a kit from a guy named Billy. His company is BD Tools. You can find him on eBay, and he makes these kits that are designed to just bolt right onto this lathe. This is a Grizzly G0602 lathe. It's a 10-inch lathe, 10-inch swing, and 22 inches between centers. So basically small bench top lathe. But he makes the kit that includes the ball screws and ball nuts, and all the machine parts to just bolt right up and mount your stepper motors, and away you go basically. So I decided to go ahead and use his kit. It requires no modifications to the lathe, so that's a nice feature. And the quality of the kit's very good. I'm very happy with it. I'm glad I decided to go that way. Mostly I decided to go that way because I was constrained for time. I built a hexacopter, autonomous hexacopter for during this same time period, so I kind of ran out of time to custom machine all the parts and everything. So this was a time shortcut. But I'd say, if you're going to tackle a project like this, just get the kit. I mean, save yourself a lot of trouble, really. It's a well-designed kit, bolts right on. Unless you've got more time than money, I'd go ahead and just pick that kit up. It's really, really nicely made. So here's the Z-axis stepper. The stepper motors I'm using are 492 ounce-inch stepper motors, NEMA 34 from Kelling. And you see here it comes with the couplers, all the mounting hardware, bolts right into the screw holes, that come on the lathe. So it's really really quick to just bolt those parts into place. I've added some homing switches this is the home switch for the X-axis. This is just a simple micro switch, mechanical micro switch. And we've got another one over here on the Z-axis. Those are just super glued into place. I'll make brackets for them if they don't work for some reason, but so far they're working fine. So I got a little antsy towards the end of the project and just decided, not to bother with making brackets or whatever. I just super glued them in place, and they seem to be working fine. So let's see. A big part of the project was reworking the spindle. So I replaced the 1 horsepower Chinese motor with a 2 horsepower 220 volt 3-phase AC motor. Let's see if I can show you that motor. Open the side door here so you can get a look at it. And you can kind of see it down there, or you can see the front of it at any rate. So that's a 2 horsepower, 220 volt 3-phase motor. It's running on a VFD. So basically I had the spindle completely apart. I put in new Timken taper roller bearings, replaced the stock bearings with Timken bearings, higher quality bearing, and fabbed up and mounted the motor mounts and modified the pulley to fit the new motor. And then I made this little metal shield here. Underneath that metal shield, which I doubt you'll be able to see real well, is the Hitachi sensorless vector drive VFD. So the VFD is kind of mounted to the back of the lathe there, and I just made this little shield to protect it and keep the swarf off of the VFD. And I also had to modify the newer motors are much longer than the original motor, so I had to modify the backsplash and lengthen this section here to fit the longer 2 horsepower motor back there, and repainted those. Looks like some of my paint chipped off here. I have to touch that up, but so yeah, those are some of the. I also had to cut a relief here in the door for the larger motor as well. So but we got a variable drive 2 horsepower motor. We've also got index wheel on the spindle. This is a little piece of acrylic here with a hole in it, and then there's an optical sensor that is reading that index wheel, and that allows the control Mach 3 to know the true speed of the spindle, so that it can sync the Z-axis with the spindle speed for threading. So that's in place. I cut that on my laser cutter, my Epilog laser cutter, and then fabbed up a little bracket to mount the optical sensor. And I've also got the fog buster coolant system going, which is a mist type coolant system, but puts out a larger droplet size just to keep the coolant on the part and out of the atmosphere, where it can be not fun to breathe. So I've got the fog buster there, and that's mounted up. And then we've got the actual reservoir for the fog buster is just on the side of the lathe here, attached to the door. And then over here we've got the control for the lathe. So this is a control I've had for some time. I built it for originally for my TAG lathe, or excuse me, my TAG mill. So I've had this control for some time now. And it's basically, well, I'll show you what's inside here. Just move the computer out of the way. And we'll pop the top here. So it's a simple little control. It's kind of turned into a bit of a rat's nest because it's grown over the years, and I've added more features and more stuff. But basically, this is on the back here is a G540 stepper motor controller. So you've got 4-axis stepper driver board there, and that also has pinouts for the inputs and outputs. These are our inputs here. That's wired to the back on a 9-pin connector. And that's actually the limit switches are coming into this connector here. This connector here is a 9-pin connector for the analog 0 to 10 volts signal that goes to the VFD, the variable frequency drive. This allows Mach 3 to control the variable frequency drive speed setting. We've got down at the bottom, you probably can't see them, they're buried under there, but there's a couple of 50-volt relays. Those two 50-volt relays are running the forward and reverse start-stop for the spindle. So they're wired to the back here. And these wires here go to the VFD, and that's your start and stop forward reverse signal for the variable frequency drive. We've got our C3 index card here, so that's reading the optical sensor for the index wheel. We've got a 5-volt power supply here, and that's powering both the C3 index card and also another card over here. We've got a C15 dual relay board. This dual relay board is powering the solenoid for the coolant system. So there's a solenoid that I've kind of mounted to the side here for the fog buster. So Mach 3 is controlling that solenoid, which turns this coolant on and off. And then of course we've got our 48-volt power supply that runs the stepper motors, runs the relays, runs the G540. And then we've also got on the power supply there is a smooth stepper board. Smooth stepper is a motion control board that offloads all the motion planning from the CPU to the board. So this does all the motion planning for the CNC control, and it also allows you to use USB instead of a parallel port. So that's wired to the back there with USB, and that emulates two parallel ports to connect to the G540 as well as other boards in the system. So and I basically wired up everything to the back panel so that you can, plug stuff in and unplug stuff easily. That's about it for the control. I'm gonna put this is a laser cut wood box that I made for it out of melamine, or not melamine, but masonite, which I also did on my epilogue laser, which my epilogue laser is right over here, and one of my favorite tools. But anyways, so that's the control, and then the computer that we're using for the control is it's a shuttle all-in-one 15-inch touchscreen computer. So being an all-in-one, the main board, the motherboard, CPU, hard drive, memory, etc., is all inside this casework for the monitor. And then, like I said, it's also got a built-in touchscreen, so we can operate the control via the touchscreen controls. So it's I got the bare bones. This is like a bare bones system. It doesn't come with a hard drive or anything. You kind of build it up with your own components. But I got it from Newegg. It's a dual core Atom 1.66 gigahertz with 2 gigs of RAM, 60 gig hard drive, and nice thing about it doesn't take up a lot of space. Just sits right on top of the control, and the touchscreen feature is nice as well. So, and it works really well. So, pretty happy with that. So that's the basic control there, and that's the lathe in a nutshell. What I'm going to try and do now is I'm going to try to do a demonstration here and show you how it cuts and how it works and everything. This is just a simple test part. It serves no practical purpose other than to test the function of the lathe. But I'm going to go ahead and fire up the spindle here. So you can see the RPM that I've set here, 2,000 RPM, and that's the index reading from the spindle. So this is our part program we're going to run. It's a simple arc, hopefully that it's going to cut into the piece here, and I think we're all touched off and ready to go. I'm going to go ahead and start the coolant as well. So coolant's fired up. I think we're ready to go. I'm going to go ahead and hit cycle start here. I'll come over to this angle. Hopefully you can kind of see what's going on. compressor kicked on there. Sorry about that. That's the compressor I have is really loud. I need to replace it with a better compressor, but thing scares me every time it comes on. I know it's going to come on, but I forget about it, and then it scares the crap out of me when it comes on. So yeah, that's the lathe project. Yeah, it seems like it's working pretty well. Nice surface finish on there, and so yeah, pretty happy with that. So yeah, my shop here is feature complete. I've got my CNC lathe, my CNC mill. So videos in the future are going to be all about making parts. So I'm done building machine tools for a while. So that's it for now. Thanks for watching. More machining videos to come.